Welcome class. How are you all? In the previous video, we have completed the theorem on areas of similar triangles where the proof has been deleted by the CBSE. Now, in this theorem, it states that the ratio of the areas of two similar triangles is equal to the square of the ratio of the corresponding sides. That means if we have two triangles over here, say triangle ABC and triangle DEF, then the ratio of the areas of two similar triangles. Keep in mind that it is given triangle ABC is similar to triangle DEF. Then in that case the ratio, that means area of triangle ABC whole upon area of triangle DEF, that means the ratio is equal to the square of the ratio of the corresponding sides. That means the sides are in proportion. So over here AD upon DE, this will be the ratio of the areas of two triangles will be equal to AB upon DE whole square is equals to the next side that we are going to take, BC upon EF whole square is equals to AC upon DF whole square. This is what the theorem says. Now in the previous class, we have already finished the first, second and the third question of exercise 6.4. Today in this video, I am going to explain from question number 4 to question number 9. So let's have a look at the exercise, and also please make sure that you write down the solution, and there are two questions which are given as homework. Please try to do it on your own. So let us begin with the chapter.
Question number 4 says that if the areas of two similar triangles are equal, prove that they are congruent. This is the question. So let us draw two triangles. Here we have triangle ABC. Here we have triangle DEF. And we are to prove over here that it is given that the two triangles are similar, they have to be congruent. Okay, so let us write the given part first. Given triangle ABC is similar to triangle DEF. This particular thing is given here. Now, if also it is given that the areas of two similar triangles are equal, that means these triangles are similar as well as their areas are also equal. So we are going to mention over here, and area of triangle ABC is equal to the area of triangle DEF. Right? This is given. Now we have to prove that triangle ABC is congruent to triangle DEF. So let us start. We know by the theorem of areas of similar triangles that area of triangle ABC upon area of triangle DEF, we know that they are equal to the squares of the proportional sides. So we are going to write over here AB will be proportional to DE whole square, which is equal to BC upon EF whole square, which is equals to AC upon DF whole square. Right? This is our first step. Now, after that, we are going to write over, we are going to open up the brackets. So we will have AB square upon DE square, which is equals to BC square upon EF square, that is equals to AC square upon DF square. Alright. Now, over here, since the areas of the triangles are equal, that means all the ratios, all the sides of the ratios are equal. Yes. So over here, we can write area of triangle ABC upon area of triangle ABC. We can write this because area of triangle DEF is equal to area of triangle ABC. This on simplification will become 1 because both over here the ratios, if you see, area upon triangle ABC and area upon triangle ABC are equal. So you have over here the ratio is equals to 1, which is equals to AB square upon DE square, BC square upon EF square, which is equals to AC square upon DF whole square. Okay, now we are going to take 1:1 ratios, the proportional sides, the squares of the proportional sides, and equate it to 1. So over here we have 1 is equals to AB square upon DE square. From here, what do we get? We get DE square, shift DE to LHS, we get DE square equals to AB square. Then with the second one also we are going to do the same thing. 1 is equals to BC square upon EF square. We have EF square is equals to BC square. Then with the third side, ratio of the square of the third side, we are going to do the same thing. 1 is equals to AC square upon DF square, which is implies the DF square is equals to AC square, right? Now, on taking square roots on all these sides, what do we get? The square roots will get cancelled. We get DE is equals to AB. Here we have EF is equals to BC, and then we have DF is equals to AC. DF is equals to AC. Therefore, we have proved that all the sides are equal. So, by triple S congruency rule, by side congruency rule, we have, what do we have? That the triangle ABC is congruent to triangle DEF by side congruency rule. Hence, we prove that when the two triangles are similar and their areas are also equal, then we can prove by side congruency rule that the triangles are congruent as well. So, here is the complete solution of this, children. Please copy it down. While writing the solution, you can pause it as well. So here is the complete solution of this. Okay. Now let us move on to the next question. Now, to begin with question number 5, let us read the question first. D, E and F are respectively the midpoints of sides BC, CA and AB of triangle ABC. Find the ratio of the areas of triangle DEF and triangle ABC. That means we have to find out the ratio. Now, first let us imagine what can be the diagram. Okay, so this is a triangle ABC. It is already given in the question. Triangle ABC. Now, D is the midpoint of BC. D is the midpoint of BC. So here is D. Then E is the midpoint of CA. Here is E. Then F is the midpoint of AB. Here it is F. Now they are asking us to find out the ratio of areas of triangle DEF and ABC. ABC is the original one. Now DEF, if you can see, if you want to draw an imaginary line over here, you have to join these two lines and you get another triangle by joining the midpoints of the three sides. Okay. So over here, what is given? We are given that D, E and F are midpoints, right? Are midpoints, it is given. Now, let us see the proof part of it. In the proof part over here, if you can see, children, now we know that D and E are midpoints of sides BC and CA. Okay, we know that D and E are midpoints of BC and CA. So over here we can write therefore DE. Therefore DE, where is DE? This is DE. We can write it as half of AB. Now why will it be half of AB? We know that the line segment, we know the reason, you all have studied this theorem in class 9, that line segment joining the joining the midpoints, line segment joining the midpoints of two sides of a triangle is parallel is parallel to the third side is parallel to the third side and half of it and half of it. This we have already studied, that line segment joining the midpoints of two sides of a triangle is parallel to the third side and also it is half of it. So with this theorem we derive that this particular line DE is equal to half of AB. Is that clear? Similarly, with respect to this, we can also state that EF, where is EF? This point, EF, okay? This line EF is half of BC, and we can also write DF, this particular line is parallel to AC, so we can write DF is half of AC. Is that clear? Now, we have written over here DE is half of AB, EF is half of BC and DF is half of AC. Is that clear? Now, from here we will proceed to the next step. So, please copy this solution down. Copy this down this much. You can pause and copy it. Now, we will move lower. Now, from here if we have to continue, we will write therefore, what do we derive? We know that half of AB is equals to DE. Okay, we know DE is equals to half of AB. Is that clear? DE is equals to half of AB. Now, if I bring this AB to LHS, I get the ratio DE upon AB is equals to 1 by 2. Okay, DE upon AB is equals to 1 by 2. Then, with this one, EF is equals to half of BC. Again, bring BC to LHS. What do we get? EF upon BC is equals to half. Again, with the DF is equals to half of AC. Bring AC to LHS. We have DF upon AC is equals to half. So you see the ratios are all equal to 1 by 2. EF upon BC is also equal to 1 by 2. DF upon AC is also equal to 1 by 2. Now with this in your mind, let us see the diagram. Let this be clear in the diagram format. Okay. Now what have we derived? That DE upon AB, this line, DE upon AB is 1 by 2. EF upon BC is equal to 1 by 2. And DF, this is DF upon AC is also equal to 1 by 2. Is that clear? That means all the ratios, all the sides are in proportion. Now, when all the sides are in proportion and are equal in proportion, so what do we see from here? We derive that DE upon AB is equals to EF upon BC is equals to DF upon AC. They are all are equal to 1 by 2. That means they are equal. They are equal. The ratios are equal and they are in proportion. So from here we derive that the small triangle is similar to the bigger one. Yes, triangle DEF is similar to triangle ABC. Triangle DEF is similar to triangle ABC. Then from here we can also state that when the two triangles are similar, we know the ratio of their areas. That means area of triangle DEF upon area of triangle ABC is equal to the square of the sides in proportion. This we can write it as DE upon AB whole square, which is equal, so you can take any side, either you take DE upon AB, EF upon BC, or DF upon AC. Now DE upon AB is equals to 1 by 2. The ratio will be 1 by 2 whole square. That is, open up the brackets, 1 ones are 1, 2 twos are 4. So the ratio of the two triangles, that means triangle, area of triangle DEF upon area of triangle ABC is in the ratio of 1 upon 4. Okay, so over here the ratio is of 1 is to 4. This completes your question. As we all know by the theorem, children, by theorem 6.6 we know the ratios of the areas of two similar triangles is equal to the square of the ratio of the corresponding sides. Here we proved that the two triangles are similar. Now, when the two triangles are the similar, over here the ratio we had to find out. Okay, so the ratio is what? It is equal to the square of the ratio of the corresponding side. Take any corresponding side. We have the measurement. We have the ratio 1 upon 2, 1 is to 2. The square of it, you have got the ratio over here about the areas as well. So this completes your question. This is your complete part here. You can pause it and write. Then this is the rest of the part. I hope it is clear, children. Let us move on to the next one. Question number 6 is your homework, children. Question number 7. Prove that the area of an equilateral triangle described on one side of a square is equal to half of the area of equilateral triangle described on one of its diagonals. First, let us understand the diagram of this. Okay. So first of all, we are going to draw a square. Alright. It is saying prove that the area of an equilateral triangle described on one side of a square. That means on one side there is an equilateral triangle. Okay. So we're going to draw an equilateral triangle here. It has to be a bit straight. Mind my lines, children. Okay. Then is equal to half of the area of equilateral triangle described on one of its diagonals. That means we have to draw the diagonal. First of all, let us name this A, B, C, D. Okay. Now, we are going to draw the diagonal AC. From here, we are going to extend another triangle. Okay, this is another triangle. Let this be Q and let this point be P. Is that clear? So, we have a square. On one side of the square, from one side of the square, a triangle, equilateral triangle has emerged. Okay, DPA. And then from the diagonal, from this diagonal, another triangle has emerged. Another triangle has emerged. That is AQC. Okay, and it is also given that the square, the equilateral triangle described on one side of the square is equal to half of the area of the triangle. That means this area is half of the triangle drawn from the diagonal. Is that clear? Now, we will mention over here, let the side of the square, let the side of the square be A of the square ABCD of the square ABCD be small a, b small a. Okay, that means this is a, this side is a, this side is a, and this side is a. Now, what will be the length of the diagonal? Okay, what will be the length of the diagonal? So, for that, I'm going to write it over here. Alright. Now this is, let this be the, we are going to take AC square is equals to AB square plus BC square. Okay, over here if you see this triangle children, triangle ABC, we can see that it is, all the angles are of 90 degree. So this is going to be the hypotenuse. So AC square is equals to AB square plus BC square. For this, to find out the, we have to prove that this equilateral triangle is half the area of this equilateral triangle. So for this we need to find the sides. Okay. Now one more thing children over here. This, let this, we have taken it to be A. Now this is an equilateral triangle. If this is A, this will also be A, this will also be A. So over here AC square we have to find out is equals to AB square. AB is length A square plus BC is also A square, right? So from here we get AC square is equals to 2A square. Shift the square to RHS, we have under root of 2A square. Now 2 is not a perfect square, so it doesn't have its root, but A square we can write it as root 2A. Okay, we can write it as root 2A. That means the length of AC is what? How much children? It is root 2A. Is that clear? It is root 2A. Now if this is root 2A, this is also an equilateral triangle. So therefore this length will also be root 2A. This length will also be root 2A. Is that clear? Now from here we can say that triangle PAD, this triangle is similar to triangle QAC. Firstly, we are going to prove that these two triangles are similar. Now, how we will prove this, children? Since it is equilateral triangle, that means all the sides, all the angles will be of 60 degree. Yes, since it is equilateral triangle, all the sides will be of 60 degree. Okay, over here. Now, firstly, before this, we are going to mention the criteria. I hope this was clear. We have to, firstly, we will mention the criteria. Okay, we will write in triangle PAD and triangle QAC, we can write that angle P is equals to angle Q, equilateral triangle, all angles are 60 degree. All angles are 60 degree. Okay, then we are going to take any other triangle you can take. I have taken these two triangles. Let us take this triangle and this particular particular angle. We can write angle PDA is equals to angle ACQ. Again we will give the same reason, 60 degree equilateral triangle, or all angles are 60 degree. Now both the angles are 60 degree. Can we write by double A criteria? Can we write by double A similarity? We can write that triangle PAD is similar to triangle QAC. Okay, is similar to triangle QAC. Is similar to triangle QAC. Now, since we have proved this, we are working upon which theorem, children, in this exercise? We are working upon the theorem of area of similar triangles. It states that the ratio of the sides, the ratio of the areas of two similar triangles is equal to the square of the ratio of the corresponding sides, isn't it? Now, these two triangles are what? Now we have said that these two triangles are similar. So, from here, we can write that now we have proved that these two triangles are similar. So, area of triangle PAD upon area of triangle QAC, we can take now this area, the ratio of the area is equal to the square of the ratio of the corresponding sides. So which two corresponding sides we will take? We will take the corresponding sides AD square upon AC square. Okay, now I'm telling you which sides we are taking. Look in the diagram. This is the diagram. Okay, we have taken AD square. Now AD, this particular line we have taken, this particular line we have taken, and what else we have taken? Upon AC square. So AC square over here is this. Okay, so we have taken AD square upon AC square. This corresponding side we have taken. Because since the triangles are now similar, we can work upon the areas. Now, AD square is how much? Since it is equilateral triangle, if you see the diagram, children, we have taken all the sides to be equal of the square to be A. AD is a side of the square as well as it is a side of the equilateral triangle. So it is A upon A square upon AC square. AC is the diagonal that we have taken out the measurement as root 2 A whole square. So we have A square upon. Now root 2 will give you how much, children? It will give you 2. A into A will give you A square. A square gets cancelled. We have 1 by 2. So from here we prove that area of triangle PAD is, bring area of triangle QAC to RHS. We have half of triangle QAC. Is that clear? From here we prove that triangle PAD is half of area of triangle QAC. Hence proved. Is that clear, children? Firstly, over here these are the equilateral triangles. Okay, this side we have taken it to be A. AD is also side of the equilateral triangle, so this is also A, this is also A. Now we have also talked about this particular triangle and this particular triangle. We had to prove that this is half of this bigger equilateral triangle. Also from the hypotenuse theorem, we have found out that root 2A we have found out to be A plus A square plus A square, 2A square. Shift square to RHS, it is root 2 A square. So from A square, root will get cancelled. We have root 2A. Okay, the measurement is now over here. Then we also prove that it is given that it is both the triangles are equilateral. So we know that all the angles will be 60 degree. So we had taken any two angles and we had taken this double A similarity criterion and proved that the two triangles are similar. Now that the two triangles are similar, the ratios of the area of the two triangles is equal to the square of the ratios of the corresponding sides. We have taken any two sides over here. AD square upon AC square is equals to, we had the value AD upon AC, we had A square upon root 2A whole square. A square gets cancelled. We have proved that area of triangle PAD is half of area of triangle QAC. Is that clear, children? Now let us move on to question number 8. Now let us start with question number 8. It is saying ABC and BDE are two equilateral triangles such that D is the midpoint of BC. Ratio of the areas of triangles ABC and BDE is. So first of all, we have to justify and take the correct answer. Okay. So first of all, let us draw the diagram. This is triangle A, B, C, and from here AD, D is the midpoint of BC. So let us draw a line D and this is your triangle BDE. Okay. So over here we have triangle ABC and triangle BDE. Now both the triangles are equilateral. Both the triangles are equilateral. That means all the angles will be what? It will be equal to 60 degree. Right? All the angles will be of 60 degree and the sides will be equal. The sides will be equal, 60 degree, 60 degree and 60 degree. Is that clear? Now, since all the angles are equal over here, we can say in triangle ABC and triangle BDE, angle A is equals to 60 degree, angle E is equals to 60 degree, angle B is equals to 60 degree, angle C is equals to 60 degree, and angle D is also equals to angle D is also equal to 60 degree. Therefore, if you compare the three angles, children, in these two triangles, we can see that angle A is 60 degree. This can correspond with angle E. Okay, BED. Angle B is common in both the triangles, and angle D is equals to angle C, that is 60 degree. So, when all the angles are equal, all the three angles corresponding to the respective other angles of the other triangle are equal, we can say by triple A criterion, by triple A criterion or similarity, we can state that triangle ABC is similar to triangle BDE. Okay. Now, let the sides of triangle ABC be A. Okay, since it is an equilateral triangle, so all the sides will be equal to A. This is A, this is A, and this is A. Now, over here, children, if this whole length is A and D is the midpoint, that means BD is equals to DC and BD is half of BC. So, this we can write as 1 by 2A, isn't it? Now, since BED is also the equilateral triangle, so this is, if this is half of A, BE will be half of A and ED will also be half of A. Is that clear? So from here we can write that area of triangle ABC upon area of triangle BED is equals to, we can take any two corresponding sides, right? So over here we can take this corresponding side BC upon BD. Is that clear? We will take BC upon BD. So this will be BC upon BD whole square. What is the value of BC? The value of BC is A upon the value of BD is 1 by 2A. 1 by 2A means A by 1 by 1 by 2 into A means A by 2 whole square, which is equals to A square whole upon A square upon 4. On reversing this, we get A square into 4 upon A square. A square gets cancelled. We are left with 4 upon 1. That means the ratio is what? It is 4:1. So which option is correct, children? Option C is correct. Is that clear? Option C is the correct one. So copy down this solution, and question number 9 also similar to this. Question 9 also similar to this. Question 9 is your homework. I hope this is clear, children. This is the full solution. You can pause and write it down.